Hello, this is question 12 on your June 2022 paper 1 from OCR. It's a bit complicated question, at least this part. So you have a curve that has parametric equations. X is 1 over t, y is 2t, and the point P is 1 over p, 2p. And we have to show that the equation of the tangent at P can be written this way. The equation of the tangent at P. So we need the gradient and the point. The point is this one, so we are going to find the gradient at this point. To find the gradient, we are going to differentiate. And to differentiate, when we have parametric equations, we can differentiate with respect to the parameter, both of them. So dy by dt is going to be 2, and 1 over t is the same that t minus 1. When I differentiate that, I have minus 1 t minus 2. So this is minus 2 t squared if we bring this minus 2 positive in the numerator. Yeah, so that's the gradient at any point. But we want at point P, so we should find the parameter at this point. And it's very easy because you can see that 2p is 2t, which means the parameter is p. Yeah, and it works with this one because we have 1 over t. So my parameter at p is going to be p, which means the gradient when the parameter is p is going to be minus 2p squared, just substituting there. And to write the line, I'm going to write y minus the y of the point is the gradient, x minus the x of the point. I'm going to use that. So y minus the y of the point, which is 2p, is gradient minus 2p squared, brackets x minus the x of the point. And now it's working with the expression until it looks like they want it to look. So y the subject. Yeah? I can expand this bracket and this goes to the other side. So I add 2p. So I have y is 2p in the other side minus 2p squared x when I multiply plus 2, and then p squared divided by p is just p. This 2p with this 2p is 4p. So I have y equal minus 2p squared x plus 4p. And that's the line in the same way that they have written. Yeah, so that's part A. Then the tangent to this curve at P, so this line that we just found, crosses the x-axis at point A. The normal to this curve at P as well crosses at another point, point B. And we have to show that ratio PA to PB is 1 to 2p squared. So let's going to see, I'm going to do like a quick sketch of what is happening. So we have our curve. Let's say it's doing something like this. I have the tangent at, let's say, P. So let's say that this is P, and this is the tangent that I just found. So it cuts the x-axis at A. And then the normal cuts the x-axis at B, yeah, the normal at point B. And they are asking us to check the ratio between PB and PA, yeah, that's what I have to find. So I have the equation of this line. I can very easily find A, yeah, it's going to be the intersection with the x-axis. So in my line, I'm going to make the y equal 0. So to find A, I'm going to make y equal 0, which means 0 is minus 2p squared x plus 4p. So 2p squared x is 4p. And x is going to be 4p divided by 2p squared is 2 divided by p. So point A is going to be 2 over p, 0. Those are the coordinates of A. To find the coordinates of B, I need to find this line first. This line is perpendicular to this one and past the point P, which means the gradient is going to be negative reciprocal of this one. Yeah, the gradient of the normal is going to be negative reciprocal of that one, which is 1 over 2p squared. 2p squared, which means the normal line is going to be y minus the y of the point, that was 2p, is the gradient x minus the x of the point. So I'm using the same point because it's p. And now to find b, I just need to make y 0, yeah? To find this point is the intersection of this line with the x-axis, so y is 0. I make the y 0, which means 0 minus 2p, so minus 2p is 1 over 2p squared, x minus 1 over p. I need to find x. So I multiply everything by 2p squared, and I have minus 4p cubed is x minus 1 over p. And from here, x is 1 over p minus 4p cubed, yeah? Or if you want, you can add and write this way, yeah? Just multiplying this by p and putting all together, but it really doesn't matter. It's going to be just more easy to work with that. So b, that means point b is 1 minus 4p to the power of 4 divided by p, 0. So I have point b here, point a here, and point p here. So what I'm going to do is to find the distance PA and PB, and I know how to find the distance between points when I have the coordinates. Yeah? So PA is going to be equal to the square root difference in x squared. So it's going to be 2p minus 1, 2 over p minus 1 over p. So 2 over p minus 1 over p squared plus the difference in y. The y of a is 0, the y of p is 2p, so plus 2p squared. And I can work a bit with the expression, but not too much. So it's going to be the square root of 2 over p minus 1 over p is 1 over p. Yeah, so this is 1 over p squared. So I have 1 over p squared plus 4p squared. I can add those two, and I have 1 plus 4p to the power of 4 divided by p squared. And I can take maybe the p squared out of the square root. So I have 1 plus 4p to the power of 4 divided by p. That's PA. Then I'm going to do PB, and then I'm going to see the ratio. PB is the square root difference in x, so this 1 minus 1 over p squared. So I have 1 minus 4. I know it looks really bad, but it's going well. Squared plus the difference in y. And the difference in y is going to be again the same. So 0 and 2p. So 2p squared. That's going to work a bit with the expression. We have the square root of this one. When I have the same denominator, so I have 1 minus 1 is 0. So I have minus 4p to the power of 4 squared divided by 4 by p. I'm going to do here. So I have 1 minus 4p to the power of 4 minus 1 over p. These two are gone. So I have minus 4p cubed, and this goes squared. Yeah? So what I have is minus 4 squared is 16, p to the power of 6. And then plus 4p squared, which is this bit here. And now I have to compare this expression with this expression. Yeah, I can simplify a bit more because I have these two squares and these ones are squared, so I can simplify a bit more. I have, if I factorize that, I have square root of 4p squared multiplying 4 to the power of 4p plus 1, no? So that can go out of the root, and I have 2p outside and 4p to the power of 4 plus 1 inside, which is this numerator, Yeah, so I have something very, very similar. So if I write the ratio PA to PB in that order, PA to PB, I have root of 1 plus 4p to the power of 4 divided by p to 2p root 4p to the power of 4 plus 1. And we have to simplify until we have 1 in PA. So what I'm going to do is multiply by p in both sides and divide by the square root. Yeah, if I want a 1 here, I'm going to divide or to multiply by the reciprocal. Yeah, so I'm going to multiply by p divided by root of 1 plus 4p to the power of 4. When I multiply by the reciprocal, here I have 1, and here I have this root with this root are gone, yeah, and 2p times p is going to be 2p squared, yeah. So I'm multiplying by the same. Remember, if I don't want to change the ratio, I can simplify multiplying or dividing by the same, yeah. And you can just think of multiplying by the reciprocal, which is this one, or multiplying by p and dividing by the root. It doesn't matter as long as you get a 1 here. And the other one is 2p squared. That's what we have to find. Yeah, and that's all with this question.